All right, now I'm going to work on solving a couple of linear inequalities. So an inequality, unlike an equation, has a inequality symbol, so like a less than or a greater than sign, or less than or equal to, or greater than or equal to, or something like that. Um, so the big difference, I mean, the process is pretty similar for solving both. Um, the biggest difference is, unlike an equation, an inequality sign, the direction or the order matters. So like, for example, um, for an equation, if I have 5 equals x, okay, if I have 5 equals x, that's the same exact thing as writing x equals 5. There's no difference between these two statements, okay? However, with an inequality symbol, if I write 5 is less than x, okay, that is different than writing x is less than 5, okay? Because on the first one, x is more than 5. On this one, x is less than 5. So the order doesn't matter for equations. The order does matter for inequalities. Um, Now, there are more than one way to write an answer for inequality. Like if the answer actually was 5 is less than x, you could have also just write x is greater than 5. And these two mean the same thing, but they are different than this statement over here. So with that in mind, though, the steps for solving an inequality is pretty much, they're very similar to solving an equation. So let's look here. I've got, I'm going to have to do another distributive property on this one. So I'm going to distribute this 4 across. So 4 times 2x is 8x. 4 times minus 1 is minus 4. I still have this plus 5. Okay, I still, and then the left, the right side doesn't change, so it's still less than or equal to x minus 13. Okay, now the general idea is the same in that I want to get all the x's on the same side together. So first I'm going to combine these like terms. I get a negative 4 and a positive 5, so that just becomes positive 1 or plus 1. The right side is still x minus 13. So now I'm gonna go ahead and gather the x's on the left side and the numbers on the right side. So I'm going to subtract x from here, subtract 1x from there. I'm going to subtract 1 from here, subtract 1 to the other side. X minus x cancels out. 1 minus 1 cancels out. Simplifying, 8x minus 1 is 7x. Negative 13 minus 1 is negative 14. So I end up with 7x is less than or equal to negative 14. I'm going to divide by 7. So 7 divided by 7 is 1, so I end up with 1x. Negative 14 divided by 7 is negative 2, so I end up with x is less than or equal to negative 2. Okay. Once again, though, there's more than one correct answer, so you could have also written the answer, instead of x is less than or equal to negative 2, you could have written negative 2 is greater than or equal to x, and that's the same thing. So either one of these would be fine. Okay, so now let's look at this one over here. This one's a little more complicated because it has 3 parts to it. I got a 4 less than or equal to 5x plus 2 divided by 3 in the middle, which is less than or equal to 9. Okay, so this is going to basically, you know how when you solve an equation or an inequality that has two sides, whatever you do to one side, you have to do to the other side. So like over here, when I subtracted x from here, I had to subtract x from the right side. If there's 3 parts, whatever you do to one part, you have to do to all 3 parts. So my goal, though, is still just to isolate the x, get the x by itself. So I've got 3 operations I'm going to have to undo. I've got, because x is being multiplied by 5, added by 2, and divided by 3. Now, whenever I've got a fraction, the easiest thing to do first is to get rid of the fraction. So I'm going to get rid of a divide by 3, I'm going to multiply by 3. So if I take this whole kind of fraction here and multiply it by 3, those 3's are going to cancel out. But if I take the middle part times 3, I have to also multiply the left and the right side by 3. So 3 times 4 becomes 12. Still have a less than or equal to sign. In the middle part, the 3's canceled out, so I'm just left with 5x plus 2. And on the right side, I've got 9 times 3, so that is just 27. Okay? So then I'm trying to get the x by itself, so I'm going to subtract this 2, which will cancel out in the middle, but I also have to subtract 2 from the right side and subtract 2 from the left side. So 12 minus 2 is 10, less than or equal to 5x is all that's left in the middle, and then 27 minus 2 is 25. So I'm left with 10 is less than or equal to 5x is less than or equal to 25. So I'm going to divide by 5, divide by 5, divide by 5, all three parts to get rid of this multiply by 5 in the middle. So that cancels out, just becomes 1x, because 5 divided by 5 is 1x, so x is in the middle. On the right part, 25 divided by 5 is 5, so I get x is less than or equal to 5, and then in the left part, I get x is greater than or equal to 10 divided by 5, which is 2. So my answer is this, that x is greater than or equal to 2, and x is less than or equal to 5. Now, unlike most linear equations, linear inequalities generally will have an infinite number of solutions, like this one does. So the solution is that x is greater than or equal to 2, and that x is less than or equal to 5, but that gives me an infinite number of solutions. Like, for example, 3 would work in here, because 3 is greater than or equal to, and 3 is less than or equal to 5. Or 4 would work in here, because 4 is greater than or equal to 2, and 4 is less than or equal to 5. But, any decimal or fraction in between 2 and 5 would work. So, like, 3.5 would work, or 3.126789 would work. Okay? Oh, the lights just went off. Okay. All right, and just keep in mind also the difference between like the less than or the less than or equal to signs. So this one, both signs are less than or equal to, so both 2 and 5 are solutions, because 2 and 5 are or equal to, but if it wasn't or equal to, 2 and 5 would not be solutions. Okay. Now the only other thing you really need to remember when working with inequalities in solving inequalities, which didn't happen in either of these two examples, it could have depending on which steps you take, but basically if you're solving an inequality, if you divide or multiply by a negative number, you have to flip the inequality symbol. So like, for example, suppose I had negative 5x is greater than 15. Okay, now so to get this x by itself, I would divide by negative 5. When you divide or multiply by a negative number, you have to flip the inequality symbol. So those cancel out and become 1x, but in the answer, instead of x being greater than the right side, x is less than the right side, which in this case would be negative 3. So whenever you divide or multiply by a negative number, you have to flip the inequality symbol. So just keep that in mind.